Here's tracking test 2, question 1a. We have to simplify this algebraic fraction. So let's put everything over 3x plus 4x minus 1. So the 15 needs to be multiplied by x minus 1 because it wasn't in the original question. The 2x needs to be multiplied by 3x plus 4 because it wasn't in the original expression, and that's already over 3x plus 4x minus 1. So we end up with this expression here. Multiply out the bracket. Be careful at this point because minus 2x times plus 4 is minus 8x. Simplify the expression. There's a minus 6x squared. It's a bit harder to factorise an expression where the coefficient of x squared is negative. So let's take out the minus sign there. Remember to change these signs here. This factorises and the x minus 1's cancel. It's arguable whether this is an acceptable answer. The mark scheme actually wants you to get rid of that bracket, to write it as minus 6x plus 1 over 3x plus 4. And there's your 5 marks. Now in question 1b we have to find f dash x. So we need to differentiate this expression here. It's a quotient, so differentiate the top one first, so that's minus 6, and leave the bottom one alone. And then there's a minus sign. Then differentiate the bottom one second, that's 3. 3x plus 4 differentiates to 3. Leave the top one alone, all over the bottom one squared. Multiply out the brackets. We've got a minus 18x and a plus 18x which cancel out. So we end up with minus 27 over 3x plus 4 squared. Here's question 2. We're given this formula and we're told that theta is 85 degrees at 11 o'clock. So we can substitute in t equals 0 and theta equals 85. To get this equation, e to the 0 is 1, 60 times 1 is 60, so take 60 away from 85 and you get 25. Also told that the temperature of the coffee is 58 15 minutes later, so let's substitute in theta is 58 and t is 15. Take 25 away from each side, divide by 60, the inverse of E is ln, divide by minus 15. Now it's a show that question, so your working has to be very clear. So from this line here, 33 and 60 have a factor of 3 in common, and then it's worth emphasising that that minus sign there goes inside as a power, and so the inverse of 11 over 20 is 20 over 11, and then we've shown that k equals this expression. In part C, we have to find the temperature, the time when the temperature reaches 50, so let's put 50 into the expression. 50 take away 25 is 25, divide by 60, we get this. The inverse of E is ln, divide by k, so we have to evaluate this expression. Now personally I don't like to put all this whole expression into the calculator in one go, I prefer to do it bit by bit in case there's any expensive errors. So I've worked out this, I've worked out that, then divide, the two minuses cancel out. It's 22 minutes, it says to the nearest minute. It does ask for the time, so the time is at 11:22. And that's question 2 done. Right, here's question 3. I need to sketch 2 graphs. In this one, this is showing my working. So I've drawn y equals 2x plus a. I've shown the points of intersection. It's arguable whether I should cross this out later, but I don't like crossing out working, so I'm going to include that as my working. And then the answer is to reflect the whole graph in the x-axis. So you can see that what was below the x-axis here has now gone above the x-axis. This point here is when x equals 0, so I put x equals 0 into there, I get y equals a. And this point here is when y equals 0, so go back to here, if y is 0, x is 2x is minus a, so x is minus a over 2. In part 2, I've got to translate this graph down by b. So whereas it crossed the y-axis at 0a, it now crosses at 0a minus b. These points are a little bit more problematic. Let's take this point here first. This graph here is 2x plus a minus b. There's no modulus signs. It's not been reflected in any way. So that's just the normal graph. 2x plus a equals b. Because what I want to make sure is that the whole y expression is 0. So if 2x plus a equals b, b minus b is 0. So 2x plus a equals b. Solve that equation, I get b minus a over 2. So that's there. This part of the graph is slightly more complex, not much, but a little bit. It's where the graph has been reflected. It comes from here. So it's where minus 2x plus a equals b. Remember, I'm trying to find out what the value of x makes y 0. So if minus 2x plus a equals b, then this whole expression will be 0. Solve that equation, multiply out minus 1, and rearrange to get x, and I get minus a plus b over 2, which goes in there. But the point about these two coordinates is that I want the y coordinate to be 0. So the equation of that line, that's straightforward, 2x plus a, but the equation of this line is minus 2x plus a. Let's go on to part b now. What we have to do is to find where 2x plus a minus b equals a third x. So here I've drawn a little sketch. There's a third x. So I need to find the coordinates a and b. So a is where y is a third x, that's a normal graph, meets the normal graph there without the modulus signs. It's this part here that's more complex, where we have to put the minus sign in, but we'll do that in a minute. So let's go back to here. That equation is 2x plus a minus b. This is a third x, so solve that equation and you end up with x is 3/5 b minus a. But to work out the coordinates here, I need to find where these two graphs intersect. This is still a third x. This bit is minus 2x plus a minus b. It's the reflected part of the modulus graph. So again, solve that equation and we end up with x is minus 3/7 a plus b. So the two solutions are given there and there. So good idea just to emphasize those. So that's question 3 done. So here's question 4. Let's make that a bit bigger. In part A, the bottom very nearly differentiates the top. There's just a factor of 4. So if we take that 4 out there, 4 times 14x plus 5 is 56x plus 20. So now the bottom differentiates the top. So therefore it's natural log of the bottom part. In part B, multiply out the bracket, sec squared times 1 and sec squared times tan squared. Integrating sec squared, that's easy, that's tan. Integrating sec squared tan x, well, it's a third tan cubed x. Because if you differentiate tan cubed, 3 times a third is 1, and then you get tan squared. Then differentiate tan, and that's where the sec squared comes from. And in part C, root x squared plus 4, 1 over that is x squared plus 4 to the minus a half, so that must have come from x squared plus 4 to the half. The half and the 2 cancel out, but you do get the 2x from differentiating the bracket. So check by differentiation, and there's your answer. In question 5, we need to find the inverse function for f. So let y equal 3 minus 2 to the minus x. Rearrange the equation. The inverse of e is ln, so we end up with this equation. To write out the inverse, you need to replace the y by the x. As far as the domain is concerned, we can't have logs of negative numbers, so x has to be less than 3, so the domain is x is less than 3. Solving the equation in part B, good idea to get rid of that minus sign so we can equate the lns. So the minus sign goes inside as a power, so 3 minus x over 2 to the minus 1 is this. So these two are equal, and then solve that equation and you get x is 1 or x equals 2. And now finally part C. It says the equation f of t is k e to the t. So I've written out the f equation again, but instead of writing x I've written t. So this part here is f of t equals k e to the t. Now this is e to the minus t, this is e to the t, so let's multiply through by e to the t. So I'm multiplying everything here by e to the t. 3 times e to the t. E to the t times e to the minus t is 1. And e to the t times e to the t is e to the 2t. Rearrange that equation. It's now quadratic in e to the t. So just to simplify things, I've written p equals e to the t. So it's kp squared minus 3p plus 2. There's only one solution, so the discriminant is 0. So b squared, b is 3, b is minus 3, b squared minus 4 times a times c. So you end up with k is 9/8. And that's tracking test 2 completed.